These are the Section 8.2 notes. You need to have your textbooks open to page 476. We're going to start talking about using the distributive property to factor things out of polynomials. Now, in chapter 7, we were multiplying. So we would take that 5z you see here and we distribute it to each piece to write it as its simplest form. But we're going to do the opposite this section and pull things out of polynomials. So first thing we learned is we learned how to distribute a monomial with a polynomial. So we know that we got 20z squared here plus 35z. Now we could do the opposite and we could have had this answer and they said factor it. Well, that means pull something out. And when they ask you to pull something out, you should always pull out the greatest common factor. And yesterday's notes, we learned how to pull out those greatest common factors, or how to find those greatest common factors. So let's take a look at this example and see if we can pull anything out of it using those greatest common factors. So I'm going to rewrite this as 5w squared plus 6w equals 5 times w times w. Then I'm going to say plus 2 times 3 times w. So all I did was I took both pieces of this binomial and wrote them in prime factorization. So I have 5w squared plus 6w written in factored form. Now I have to take their greatest common factor and factor it out. So what do they have in common? They don't have any 5s, they don't have any 2s or 3s in common. They do have one w in common. So the only thing we can pull out from this is a w. And what I'm going to do is I'm just going to write that w that they have in common on the outside of parentheses and then write what's left. So I used this w from both of them. I pulled it out of both pieces and I have 5w plus 6 left. Now let's see, if I were to take that w and distribute it back in, would I get my original problem? 5w times w gives me 5w squared, plus 6 times w gives me 6w. I do make it back to exactly what I started with. So I can take everything that they have in common and pull it out, and I get the same thing. So factoring polynomials involves finding the completely factored form. So let's take this one for example. I have 27y squared plus 18y. So let's rewrite this. I have 27 is the same thing as 3 times 3 times 3. 3 times 3 gives me 9, times 3 gives me 27. Times y, plus 18, which is 2 times 9, which is 2 times 3 times 3, times y. Now I'm only going to take the things that they have in common. They have no 2's in common, they have 2 3's in common, and they have 1 y in common. I'm going to pull those things that they have in common out. So their greatest common factor is 3 times 3 times y, which is 9y. I write that on the outside of the parentheses, and then I write what's left. 3y plus 2. Okay? So this was actually step 2, which goes down here. And I factored out the GCF. So when I pull that 3 times 3 times y out and put it on the outside of the parentheses, that's called factoring out the greatest common factor. So that is the final answer for that question. Turn to the next page. Let's try another one. Now, we were doing binomials on the previous page, but you can have them as big as you want, as long as they have something in common. So let's try this one. I have -4, which is -1 times 2 times 2 times a times b minus 8, which is 2 times 2 times 2 times a times b plus 2 times a times b. Okay, I'm going to come back here to this minus 8ab squared, and I'm going to put it as plus, and then -1 times 2, that's times 2 times 2 times 2. So I took that and I made it a plus and negative, and so remember for the -8 I have to put -1 and then 2 times 2 times 2 gives me that 8. So now let's circle what we do have in common. These ones have negative 1s in common, but this one does not, so we can't include those. This one has a 2, 2, and 2, so they have at least 1 2 in common. Circle those. Now, this one doesn't have any more 2s, so we can't use any of these. This one has an A, this one has an A, and so does this one, so they have an A in common. And they all have one B in common. Okay? So let's go ahead and write out what the prime factor, or the greatest common factor is. So I have 2AB. I pulled that out, and then I write what's left. Negative 1 times 2 gives me negative 2A, plus negative 1 times 2 times 2 gives me negative 4B, plus, now I don't have anything left, but that doesn't mean I put 0. I'm going to put 1. So 1 times 2 times A times B gives me that 2AB. So if there's nothing left, you just put 1. So let's go ahead and take a look. I have 2AB as my greatest common factor, parentheses, negative 2A, plus a negative 4B, plus 1. Now if I have plus a negative 4B, I'm going to rewrite it as just minus 4B. So 2AB, negative 2A, minus 4B, plus 1 is my final answer. So I want you to go ahead and try number 3 and 4 on your own. Pause the video, come back when you're ready. I have 15W minus 3V, so I'm going to write these as 3 times 5 times W minus 3 times V. The only thing they have in common is a 3, so I just factor a 3 out and write what's left. V, or 5W minus V, is my final answer. On the next page, I'm going to rewrite it as 7 times U times U times T plus 3 times 7 times U times T plus a negative 1 times U times T. So let's take what they have in common. They don't have any 7s in common. They each have 1 U in common. And they each have 1 T in common. So I factor out what they do have in common. I have U, T, and then I write what's left. 7UT plus 21T. And I'm just going to leave this as minus 1. There was nothing left here, so I have to include that 1. Okay, and that's my final answer. Now, factoring by grouping is another method we can use, and the definition for this is on page 477. It's for factoring polynomials with 4 or more terms. And it's just like the name says, you put them in groups and then see what you can factor out of each of those groups. So here's what you need to know. If there are 4 or more terms that have common factors that can be grouped together, and there are 2 common factors that are identical or additive inverses of each other, then it can be factored by grouping. And this seems like a lot of stuff to remember. You'll see how these work in the examples that we do together. So if I have AX plus BX, and then AY plus BY, I can factor this by grouping because, do you see how I could group this AX plus BX and factor an X out? And then I have AY and BY, and I could factor the Y out. And then I would have A plus B, and then I can deal with the X's and Y's. And that seems like a lot to take in. You've never done this before, so just follow along. So what I'm saying is, let's group all the terms that have X's. So I have AX plus BX, and then plus AY plus BY. So in this group, I can pull an X out. If I pull the X out, I'm left with A and B. If I'm in this group, they have a Y in common, and I can pull the Y out. So I have Y, A, and B. Now looking at this step, this term and this term have an A plus B in common. So I can factor that out, and I'm left with X plus Y. So I have X plus Y times A plus B. And that's a lot to take in. When we do this together, it'll become easier. Turn to the next page and we'll try one of those examples. So let's take a look. I have 4QR plus 8R plus 3Q plus 6. Now, these ones have an R in common. They also have a 4 in common. These ones have a 3 in common. So let's group these together and see what happens. If I take 4QR plus 8R and put it in parentheses, plus, this plus comes down here, 3Q plus 6. Now I'm going to deal with each individual group by factoring out things it has in common. In this one, I know that a 4 can come out of each of these, and so can an R. Now, if I factor a 4 out of here, I'm left with the 4 is gone. The Q is left, and then I also factored an R out, so all I have is Q. Plus, I factored a 4 out of the 8, which leaves me with 2. I also factored an R out, so I'm just left with 2. Plus, over here, 3 and 6 both have a 3 in them. Q is left alone, plus, if I factor a 3 out of the 6, I get 2. Now you should notice that the Q plus 2's are the same. So because they're being multiplied, I can factor them out as well. Each of these things is being factored by a Q plus 2. What's left goes on the inside of parentheses, 4R plus 3. So there's nothing more that can be pulled out of here, and there's nothing more that can be pulled out of here, and this is factored. So let's go ahead and try this next one. I have Rn and 5n. What do they have in common? An n. And then I have negative R and negative 5. They have a negative 1 in common. So let's try grouping. I have Rn plus 5n, and I'm going to say plus negative R minus 5. Now, the reason I said plus is because I'm grouping this, so I have to include their negatives on the inside, so I'm making this plus a negative. So, out of this one, I can factor an n. If I factor that n out, I'm left with R plus 5. Plus, now this one, I can factor a negative 1 out. I should have left that negative 1 out there. And then in parentheses, if I take the negative away, I'm just left with R plus 5. Now, I factor that negative 1 out, so this will sign change. Notice I have R plus 5 and R plus 5. Because they are the same, I can factor them out. So I have R plus 5 times what's left, which is n plus a negative 1, or n minus 1. And I'm finished. Okay, I know these are a little bit tricky, but I want you to go ahead and try number 3 on your own. Pause the video and come back. I'm going to group 3np plus 15p, and then plus negative 4n minus 20. I can factor out a 3 and a p, and when I do that, I just have n plus 5 left, plus I'm going to factor out a negative 4, and I'm left with positive n plus a positive 5. Notice n plus 5 and n plus 5 are the same, and because they are the same, I can factor it out times what's left, which is 3p plus a negative 4, or minus 4. And I'm finished. Now, something else we need to keep in mind is you can have something called an additive inverse. And here's an example of that. I think what I'm going to show you is I have 6 minus a, and that's the same thing as if I factor a negative 1 out. If I factor a negative 1 out of this, I take negative 1 out of positive 6, which gives me negative 6, and then makes this negative a positive a, which means I can rewrite it as negative 1 times a plus a negative 6 because of the commutative property, or negative 1 times a minus 6. Now, you'll see why in this step that makes sense, and when we're doing this example, we'll refer back to this. So this is an example of when you would need to look out for your additive inverses. So let's start by factoring. I'm going to say 2mk minus 12m plus 42 minus 7k. Okay, let's start by factoring what I can out. I know I can take a 2 out and I can take an m out. I'm left with k minus 6 plus, now I know I can factor a 7 out of these. I always forget to leave a little room. So 7. Now 42 divided by 7 gives me 6 minus k. Now these are really close, right? But they're not quite the same, so I can't factor them out. But if I look at my additive identity rule, if I factor a negative 1 out of this second one, I can rewrite it as negative 1 times a minus 6, or k minus 6, right? Because I have that 6 minus k, I can rewrite it as negative 1 times a minus 6, which will make that k minus 6 the same. So I'm going to leave that first term the same. I have 2m times k minus 6 plus, now I factored a negative 1 out, so I have 7 times negative 1 times, and then I just reverse these to k minus 6. Okay, so now I'm going to rewrite it as 2m k minus 6 minus 7, because plus a negative 7 gives me minus 7, times k minus 6. Now my k minus 6's are the same. I can factor them out, and I write them times what's left, which is 2m minus 7. And I'm done. Additive inverses, I think, are one of the harder things to do when you're factoring by grouping. You just have to keep in mind that if you see something like this, where you have k minus 6, 6 minus k, you have this special rule that lets you rewrite it so that they are the same. Turn to the next page. Let's do one more of these together. So I have c minus 2cd plus 8d minus 4. I'm going to factor a c out of these. I'm left with 1 minus 2d plus, I'm going to factor a 4 out of these, 2d minus 1. Now I'm going to factor a negative 1 out of this so that I can switch these around so that they look the same. So I have c 1 minus 2d plus 4 times that negative 1, and then I can rewrite these as 1 minus 2d. These are the same. So I can factor them out. I get 1 minus 2d times what's left, c minus 4. And I'm finished. Okay, I want you to try number 3 on your own. Come back when you're ready. So I have 3p minus 2p squared minus, now I'm going to actually write this as plus a negative 18p plus 27. Okay, so I can factor a p out of this, and I'm left with 3 minus 2p. Plus, I can factor a 9 out of here, and I'm left with negative 2p plus 3. Now, what do you see? I have negative 2p and 3, but one of them has to change. So I'm going to factor a negative 1 out of this. I'm left with p 3 minus 2p plus 9 times negative 1 times 3 minus 2p. And all I do is change them around. So now let's take a look. I have 3 minus 2p factored out times p minus 9. Okay. Turn to the next page. We can also use factoring to solve equations. So we were just factoring monomials, which are just expressions, but now I'm going to talk about equations. Remember, the difference is that an equation has an equal sign, and we do that by talking about a zero product property. Now, if I make an equation equal 0, I can say that either of the factors equals 0 and find each factor. So that seems kind of confusing. I want you to turn to page 478. If I'm looking at this, 3 times 0 equals 0, right? So one of the factors of this equation is 3, the other factor is 0, and it gives me 0. Same thing here. If I distribute this 0, I get 0 minus 0 gives me 0. Same thing here. 312 times 0 gives me 0, which means anything times 0 is just 0. And you're like, why does that matter? But when I start looking down here, if I have this number times this number equals 0, I know that either one of them or both of them have to equal 0, because the only way to get a multiplication problem to equal 0 is if one of these or if both of them equals 0. So the zero property product is if the product of two factors is 0, then at least one of them equals 0. Okay? In other words, if A times B equals 0, either A is 0 or B is 0. They both can be 0 at the same time though. So what that means is, all right, I know how to factor, I know what I'm doing, I can split them up, but now I have them equal to 0. What do I do? Well, either 2D plus 6 equals 0, or 3D minus 15 equals 0. So what you do is you take each individual one, you're going to say 2D plus 6 equals 0, or 3D minus 15 equals 0, and you're going to solve both of these equations. So start by subtracting 6, 2D equals negative 6, divide by 2, D equals negative 3. Or add 15, 3D equals 15, divide by 3, D equals 5. So we have our two possible factors that would make this equation true. Turn to the next page. Now sometimes they're not going to write them equal to 0. You need to rewrite them equal to 0, then factor, and then find each of your factors. So over here, I'm going to subtract 3c. I'm left with c squared minus 3c equals 0. This is when I'm going to start factoring something out. What did these have in common? Just one c. So we're going to take c times c minus 3 equals 0. So either c equals 0 or c minus 3 equals 0. Now this one's already solved, so I can add the 3 to this one, and I get c equals 3. So either c equals 0 or c equals 3. So let's try this one next. I have 3n equals 0 or n plus 2 equals 0. Divide by 3, either n equals 0 or subtract 2, n equals negative 2. Those would be your two answers. Now this one has not been factored. Let's go ahead and factor it. So I can pull an 8 out of both of these. I can also pull a b out of both of them. I'm left with b here minus 5 equals 0. So either 8b equals 0 or b minus 5 equals 0. Divide by 8, b equals 0, or add 5, b equals 5. Now on this one, remember I have to bring this to the other side and make it equal 0. Add 10x to both sides, and I get x squared plus 10x equals 0. I can't factor anything from the 10, but I can factor an x out. So I get x plus 10 equals 0. So either x equals 0 or x plus 10 equals 0. This one's done. Subtract the 10. X equals negative 10 or 0. Now, that might have been moving a little fast. We'll go over some more examples tomorrow in class. If you have any questions, make sure you let me know. This is a lot to take in, so when you are taking a look at your homework or trying these, make sure you take your time. The hardest thing, I think, is that additive inverses. I would review this a little bit before you move on. Okay, see you tomorrow.